Welcome. So I'm going to do, I'm kind of in an echo chamber down here. We're going to do a little review on unit circle and then go into something that's not a unit circle and make you realize that, oh, it's really just SOH CAH TOA in disguise. So don't let the fact that we throw some things that are not unit circle in there throw you off from your powers of SOH CAH TOA. The unit circle, we originally figured out that the cosine of theta, whatever degree, 30 degrees over here or 15 degrees over here, is equal to x over 1, or adjacent over hypotenuse, since our radius of 1 is really a hypotenuse. And same thing with the sine. So, and we use that in this special right triangle to figure out that this is square root of 3 over 2, or roughly 0.866 wide, and roughly 1/2, not roughly, exactly 1/2 high. In the same way, we learned that 15 degrees over here, or 175 going this way. If I take the cosine of 175, I get negative 0.97, and if I take the sine of it, I get 0.26. So in the unit circle, what's super convenient is the cosine and the sine are exactly x and y. And the reason this is this multiplier here, this what we might call a scale factor, doesn't have any effect, or it doesn't look like it has any effect, because it's 1. I'm pointing at things you can't see. So in a minute, we're going to change that, and we're going to have some other things happen here. But I want to point out one problem you might get that'll throw things off. Maybe I tell you the tangent of theta is negative 0.7563. So one way to figure out what theta is to take the inverse tangent of both sides, and the way we write it is this way. Okay. Sometimes we say tan negative 1, but the proper way to say that is inverse tangent. And we show the teacher what we're doing by saying I'm doing the same thing to both sides of the equation. I'm doing the inverse. And then when I throw that into the calculator, I just had it queued up, but I think I lost it. Second, tan, make sure you are in degrees. Negative 0.7536. And I get negative 37. So theta is equal to negative 37. And you think, great, it is basically right here. Now that's a little misleading, because the other way we can find tangent is we can say, well, the tangent of theta is equal to the opposite, which happens to be the y value, and the adjacent, which happens to be the x value. Now, this is a negative number. We actually don't know which one of those two is negative. One of them definitely has to be negative, and one of them has to be positive. And that quadrant would be completely correct, because we have a positive x value and a negative y value down there. But it could also be up in this quadrant up here, where I have a negative and a positive. So actually right now, all we know is our reference triangle is 37 degrees. We don't know which quadrant this is in. So we need more information to do this. And if I told you the x or the y value, or the x or the y value, then you could figure out which quadrant it's in and get it in the right place. But just because when you do an inverse of really anything, it doesn't necessarily tell you which quadrant it's in. If you do the inverse of a sine, it just tells you it's in, if it's positive, it's in the top 2 quadrants, and if it's negative, it's in the bottom 2 quadrants. And in the same way, if you do the inverse tangent of inverse of cosine, positive just means it's on this side of the graph, and the negative means on this side of the graph. You really need 2 points to determine which quadrant it is. You know the reference triangle, you know how high it is, you know how wide it is, but you don't actually know where these lands. So if you get a problem like this, take a second look and see if you can't do a little detective work to figure out, oh, actually I could be down in this quadrant, but maybe I'm up here. And so instead of being negative 37 degrees, which would be down here, this is actually up here, and it'd be 150 minus 37, or 143 degrees. At this point, we don't know, but if I told you which one of these two was negative, you would immediately know which quadrant we're in. Okay, so that was a little review. We're going to do some stuff with a not unit circle. And this can throw people off a little bit, but if you just always go back to your triangles, it's never going to be wrong. So it's a little bit off the screen there. That's a 3-5 up there. Let's see if I can do this without screwing up my camera. So this is a 3-5 up here. And yeah, 3-5. Everybody see it? this is not a unit circle, so this is not 1. So the question is, well, how, we already have the y value, we have the x value, which correspond to our opposite and our adjacent. And so the question is how you figure out the angle. Well, the same way you probably always did. You'd say, you could figure out, this is 3, this is 5. You could use Pythagorean to figure that out, or you could say the easiest way is tan of theta equals 5 over 3, and then take the inverse tangent of both sides. And I've got this written down somewhere. It is, oh shoot. Let me check my calculator here. I won't scroll up. Oh, no, I know what that's going to be. So 5 divided by 3, inverse tan. Second, sorry, taking a longer here. 5 divided by 3. It's 59 degrees, okay? And this is definitely, we don't have to worry about which quadrant it is because we can see what quadrant it's in. It's up in this quadrant, so that's a positive 59 degrees. That totally works. Now the question is, what's this other side here? Well, there's 2 ways we could figure out. One, we could figure out by doing we could do Pythagorean, but the other way we could figure out how long that hypotenuse is, which is the same as the radius. So think, hypotenuse and radius are basically the same thing there. I could also do something like, the cosine of 59 degrees is equal to 3 over hypotenuse or radius, however I want to write it, and then just work that out. So I'm going to end up having h come over. I'm going to do 3 divided by the cosine of 59, 3 divided by cosine 59, and I get 5.8. Actually 5.8, let's go to 3 places, 825, which is roughly the same value I'll get if I do 3 squared plus 5 squared and take the square root of it. But there's more than one way to do that, and if we don't have a picture in front of us, this might be the easiest way to do that. Kind of along the same lines down here, I don't know what this weird part of the circle is. Maybe I give you the degrees. Now this is 50 degrees technically, it's a negative 50 degrees, but maybe I'm talking reference triangle and you can see which quadrant it is. So I might not write that as a negative 50. It's a 50 degree reference triangle. And maybe I know this is 6y. The question is, what's the radius of that unit circle, or what's the radius of that circle that that point lies on, as well as what's the y value of that circle. So once again, I think this gets a little confusing because people start thinking about it in terms of circles, but if you just think about it in terms of, I have a little right triangle, what are my missing pieces? That's all we really have to do there. So in this case, we know that my adjacent is 6. Doesn't matter which one I can find first. I can use, let's find that one first. So 6 over opposite, or the, did I get that backwards? I did get that backwards. If I'm going to put it on bottom, I want to do y over 6 equals tangent of 50. Now technically that is a negative 50 now, or I just need to keep in mind that I know my y is going to be positive. I'm going to change it to a negative 50. But if I don't, I just have to remember my y has to be positive. It has to be negative at the end. All right, so if I take the tangent of 50, I get 1.19, or a negative 1.19 if I put in a negative, and then I multiply that times 6. And so I know this has to be a negative 7.15, which makes sense. This is a bigger degree. This has to be the bigger side. It definitely has to be negative. And then I could use that same trick with cosine or sine to find that, or at this point I can use Pythagorean theorem. All right, I want to show one last one from the worksheet, just in case people think this doesn't translate to what we're doing in class. Very first one here, 27 degrees. I am, oops, can't see it. My problem is this. It's 27 degrees, and my low power button just came on. And I know that my y is 1.362. So I know immediately this is not a unit circle, because it has to be, my y has to be less than 1 if it's a unit circle. So my hypotenuse is bigger than 1. The question is how much bigger. So I know the y is opposite, so I'm going to use sine of 27 degrees equals 1.362 over, let's see, over the hypotenuse or radius, whatever I want to call that. Okay, so I do the sine of 27, and that's 0.4540 roughly, and that's 1.362 times h, multiply both sides by h, and then divide by the 4.4540, and 1.362 divided by my answer, and I get roughly 3. And I will say for this worksheet you're doing, if you get anything that's not a hypotenuse, that's very close to either a whole or a half value, like 3.5 or 2.5, something's probably wrong. So that's kind of a checkpoint you can do. So in this case, my hypotenuse is 3, and then I can use that to figure out everything else. Because for my x, I can simply say, oh, well, I know the cosine of 27 equals, oh, do I even need that now? No, I do, because I don't know my adjacent. That's my x value. And I know that's over 3. So now I have everything I need. And what you'll notice here is, oh, I'm just multiplying this times 3. This is now your scale factor. Once I know my hypotenuse, essentially, I can just take my cosine and my sine and multiply it times my scale factor. That's another trick you can do. And I think that's probably enough. Ciao.